Alright, okay, before we start any mechanics 2 topics, we are going to start off with this thing called the Newton's second law. Okay. Basically, in equation terms, it is the summation of forces, summation, this is a summation sign, is equals to mass times acceleration. Okay, where mass is the mass of an object and acceleration is the acceleration by the object. Okay, force is just any external forces acting on this particular object. So now let's take a look at this certain object here. If I have a block and it is being pushed by different forces, okay, let's even add one more over here. Okay, so I have F1, F2 and F3. Okay, and I say that eventually, right, this whole object is going to move in this direction. Okay, and when it moves in this direction, it has an acceleration A. Okay, so this is where we apply our F equals to ma. Okay, before that we have to split all these forces into their vertical and horizontal direction component. Okay, horizontal and vertical, which means because they are all vectors, right, they all have their individual x and y components. Take for example F1, the x component of F1 would look like this. Okay, so this is, let's call this F1x. Okay, so this is how you draw it. Okay, and then the y component would look like this. So this is F1y. Okay, likewise F2, the horizontal component is this way. F2x, the vertical component, F2y. Okay, and last but not least, F3x will be pointing to the left side, and F3y would be upwards. Okay, once you split them into their individual component, you do not need to consider the blue one, the original direction anymore. Okay, you only need to focus on x and y components. And lastly, acceleration you must also split. Okay, which means my acceleration has a horizontal component. Okay, so I call this ax, and it also has a vertical component. Okay, which is ay here. So this one will be ay. Alright, and now we have split into vertical and horizontal. We can use the second law in two directions. Okay, the first one will be summation of forces in the x direction is equals to max. Okay, and then the other one will be summation of forces in the y direction is may. Okay, so you will have two equations lah. Right, and let's look at how you are going to write out the forces here. First of all, you look at the direction of ax. Okay, ax is pointing from left to right. Okay, this means that any horizontal force that is pointing from left to right will be a positive component, and any horizontal force pointing the opposite way will be negative. Okay, so we have one positive, two positive. F3x will be negative force. Okay, so how you write? You should write F1x plus F2x minus F3x equals to max. Okay, the same applies to y, because ay is pointing upwards, so whatever forces pointing downwards will be negative. Okay, so F1y will be negative, so you have to put minus F1y. F2y is positive. F3y will also be positive. Okay, equals to MAY. Okay, in this way you will be able to solve the whole equation, the whole system by solving these two directions. Okay, yeah. So the next thing I'm going to talk about is called the static equilibrium. Okay, so you see, summation of the forces is equals to MA, right? Okay, sometimes it is equals to 0. Okay, under what circumstances is it equal to 0? Okay, of course the first one is when everything is stationary. Okay, when your object is not moving, there's no velocity, there's no acceleration, so sum of forces equals 0. Okay, and the other case is when your object is moving under constant velocity. Okay, so if my velocity is constant, I have no acceleration, so A is 0, so the whole right side is equals to 0. Okay, so under this circumstance it will be 0. Okay, so in that case, let's give an example again. Okay, for example, your object here now is on a flat surface. You are applying a force P. Okay, so by right, there should be friction coming from the surface onto the object. Okay, in the opposite direction, friction F. Okay, just imagine the calculator moving on the surface going this way. Okay, to the calculator, the ground is doing this force, applying this force onto the base of the calculator. Okay, that's why the friction is this direction. Okay, opposite the motion. Okay, so this is constant velocity. Okay, so in this case, your sum of forces would be 0. Then your next question will be, hey, then which one is positive, P or F? The answer is it doesn't matter, because if I set pointing right to be positive, then it will be P minus F equals to 0. If I set pointing left is positive, then it will be minus P plus F equals to 0. Both will give you P is equals to F. So both forces will balance out. Okay, if there is no velocity, no acceleration. All right, so this is called static equilibrium. Okay, which a lot of cases later on you encounter will have the same situation, and then you don't have to consider the direction. Okay, but if there is an acceleration, then the direction that follows the acceleration will be considered positive. All right.